Okay, in this video, we're going to look at graphing the derivative of a function. So we're just going to work through an example to do this. So we've got a function graph below f at x. So here's our function f at x. And we want to sketch the derivative. So when I say sketch, I mean we're just going to kind of estimate what it looks like. We're not going to actually calculate the equation of f prime. We're going to estimate by using tangents. So the way we're going to do this is I'm going to kind of do a table of values. So I need to pick some x values to use. So I'm going to use, for this case, 0, 1, 2, 3, 4. And now, I mean, this is a graph I've drawn by hand, so it's not super accurate. So it's very much going to be an estimate. And then this side here is going to be my derivative. And remember, the derivative represents the slope of the tangent at each point. Now this is going to be an estimate, with the exception of maybe one point. So the easiest point to actually figure it out for this example is 2, because 2 is the minimum. So what's the slope of the tangent at 2? Well, if I were to draw the tangent, we should be able to see, because it's a minimum, the slope of the tangent is 0. Now at the other points, I'm more or less going to be estimating. So for example, at the point 1, if I were to draw the tangent there, it's going to look something like that. So you're going to have to estimate the slope of that line, considering the scale and remembering that slope equals rise over run. So you should be able to see it's a negative number. The slope is negative. If I were to do like a triangle where I'm trying to calculate rise and run, so the rise is bigger than the run, so that means I'm not sure exactly how much. Remember, you're estimating, but let's say it's about -2. Okay, so we're estimating -2. Well, how about on the other side at this point over here, 3? So again, I'll draw the tangent, something like that, and I'm trying to estimate the slope of this line. So rise, run. It goes up faster than it rises. So again, let's say it's about 2. Now at 4, for here, this point here, it's steeper than it was at 3. And as it gets steeper, it's going to be much harder to estimate the slope, because the rise and the run, the rise is going to become much bigger, and it's going to really depend on how well you draw that line. But I can see it's steeper. I'm not really sure what it is. I know it's steeper than this line. Let's say maybe it's about twice as steep. So 4, and then just based on symmetry over at 0, we draw the slope, and again it's steeper than it was at -1. If I guessed 4 for this one, then this one's going to have to be -4. And now I'm just going to plot those points on the graph. So at -2, 0, that's a point. At 3, 2, that's a point. At 4, 4, that's a point. At 1, -2, and at 0, -4. So down here. So this blue points represent the graph f prime. So this is f prime at x. Okay, so this is how you would graph estimating by using a table to graph the derivative. So you just have to calculate each derivative or each slope, or you have to look at the slope and sort of estimate what the slope is, and then that's going to correspond to a point on your graph, which you would connect to get the derivative. Now in this case, we did know that f was a parabola, and we've calculated the derivative of parabolas, and we know that the derivative of a parabola is going to be a linear, so it does make sense that this is a straight line. If it wasn't, we know something went wrong. Now, you're probably going to have to do more complicated examples, so you might get ones, let's say a cubic. So here's another graph, f at x. So again, we're going to set up our table of values, and we always have to pick which numbers to to put in our table of values, I'm going to suggest any point where there's a max min, you definitely want that in there. So let's -1 should be in there, and this one 3 should be in there. But let's go all the way from like -2, -1, 0, 1, 2, 3, 4. Let's try to estimate the slope at all these points. So the slope at -1 and 3, that's the easiest one to estimate because those are your turning points. So those have horizontal tangents, so their slope is 0. So at -1 we get 0, and at 3 we get 0. Now let's try in between there. Let's try at this point here. If we were to draw the tangent line there, we get something like that, which looks to be about -1. It's definitely negative, and the slope, the rise and the run look to be about equal. So at 1, we're going to say we get a slope of -1. At 0, it's here, it's not quite as steep as it was here, so maybe a little bit less, maybe like -0.5. And at 2, kind of similar, it's still negative, but again, probably not quite as steep as it was here. So maybe about a half. It might be a little bit steeper, but it's hard to tell when it's when your scale is not great. The key points are the minimums for sure, and the fact, as long as, well, this would be negative, as long as you have the negative signs, you should end up getting a pretty good graph. At 4, right here, now, so now it's a positive slope, and this looks to be maybe about 1 as well. So the rise and the run look about equal. And then at -2, let's say about the same. Let's say it's about 1. So the rise and the run's about 1. Here, I'll do this. Now we'll do the graph. So we just have to plot these as coordinates. So -2, 1. So -2, 1. So we get a point there. I'm missing. So -2, 1. Right there. Oh, a little high. Right about there. -1, 0. Right around there. 0, 1/2. About there. And then 1, we're at -1. Should be about there. At 2, we were at -0.5. So that'd be there. And at 3, we're at 0. So that's there. At 4, we're at 1. So we get something looking like this, which looks like a really flat parabola, which makes sense. You know, we had a cubic looking graph. We know that the derivative of a cubic is a quadratic, so it makes sense that that's the graph we got. But this is how you would estimate the graph of a derivative. You're going to have to estimate the slope at a bunch of points and then just plot those points on your graph.